we're going on, and I'm very happy to introduce Eduardo Neves from the University of São Paulo. And I asked him to present his project titled Far from Pristina, What Lessons Can Amazonian Archaeology Teach to World Archaeology? Eduardo.
Thank you very much. Good afternoon. It's an honor to be awarded this prize. And I would like to thank the organizers of the Shanghai Archaeology Forum. I'll be talking about ongoing research that we're doing in southwestern Amazon, but it's important before I get going to say that the Amazon basin is almost the size of the continental US, and we have around 15 research groups working in the area. So everything that we do in the Amazon today, in terms of archaeology, is still preliminary. We're still building up some knowledge, some basic knowledge about the deep history of this region. But there's a consensus, remarkably, among archaeologists. I mean, archaeologists like to disagree a lot, but everybody who works in the Amazon agrees, archaeologists at least, that Amazonian biomes have been transformed by indigenous population in the past. So the idea is that we think of the Amazon basin as some kind of pristine forest that has been barely occupied in the past. But the archaeological data that we have and other people working there have as well show that indigenous people who have been living in the Amazon for more than 10,000 years have actually changed and modified those landscapes there. And I like to use this image here. That's not from the Brazilian Amazon, it's from Ecuadorian Amazon. But this looks like a typical frontier settlement in the Amazon. We see some open areas and also cattle ranches and areas covered by forests as well. But there's been LiDAR surveys done there, and you can see that this whole place is covered by earthworks. It's like a fully loaded landscape with evidence. Everything that you see there, it's squares and rectangles are like artificial earthen mounds, which were built by people who lived there starting 2,700 years ago. So this is a very dramatic image, but I think it's really valid for many places in the Amazon as well. And we know that this pattern of like landscape transformation became very clear around 2,500 years ago, but you don't really know when it started to unfold. And we don't know that very well because the Middle Holocene is a time period not very well known in many places in lowland South America, around like from 7,000 to 3,000 years ago. But there are two areas in the Amazon where we have better data about the Middle Holocene. Here at the bottom, the Upper Madeira Basin, where we'll be talking about this afternoon, and then the estuary of the Amazon further to the north. That's the main Amazon channel that you can see in the middle of this image here. So the Madeira River is the largest tributary of the Amazon. It has its headwaters up in the Andean highlands in Bolivia and Peru, like around 6,000 meters, and then it goes down towards the central Amazon. It's a white water river, as you can see here, and it brings lots of sediments, sedimentary loads along its floodplains. What's interesting about this area, now we have a long sequence of human occupation there, but what we do know about this area is like high language diversity. Each color that you see here represents a distinct language family. If you think of Europe, for instance, we have basically two major language families represented in Europe, and here we have dozens of distinct language families. That's a common Amazonian pattern, like more than 300 languages are found spoken in the Amazon, but particularly in this area here, southwestern Amazon, this pattern of language diversity is even much higher. Also, we know about this area. If you look at this map here, then we know today that this southwestern Amazon, it's an area of independent plant domestication in the past. I mean, those maps, they change from time to time, but we know that there are few independent centers of plant domestication in the world, and at least we have two of them in South America. One in the Andes, I think the whole Amazon actually is a major center of plant domestication and management, but this area here in southwestern Amazon, which is this rectangle that you see in the bottom here, I don't have the light here. We know today genetic data, and we're bringing the archaeological data to show that this is an independent center of plant domestication as well. And we've been trying to test these ideas of early plant domestication by what I want to show today is work that we're doing on two sites in this area here, where we have direct archaeological evidence of early plant domestication. The first one is a site called Teotônio, which is located next to the Madeira River, Teotônio Rapids that you see in this picture. mean, this site it's been known by people working there since the 1980s. We started working there again in 2011, and we've done several interventions. I don't have the maps to show you here. We were able to identify, deep stratified deposits with ceramics and anthropic dark soils, an occupation that starts around 9,000 years ago. We have some interruptions on the sequence, but goes all the way to the colonial period. Particularly interesting to us are these 5,500 years before present mid-Holocene deposits. We find that that's a heart, there's an anthropic dark soil, we find lithic objects and some ceramics associated with these deposits. What is interesting is that we have evidence there of plant management and domestication going back to 5,500 years ago. So it's some plants such as maize, beans, and squash, but also tree crops being cultivated there around 5,500 years ago. Another example from the same area is a shell mound, the fluvial shell mound that you can see here in the foreground, called Monte Castello. Both sites, we're still working on them. We'll be back to this place here in February. That's an artificial shell mound, which has also been excavated previously before us in the 1980s, but we're able to relocate this site. And you can see the shell matrix there. So the conditions of preservation are very good. Normally in the Amazon, the soils are very acidic, and they don't lend really good conditions. Like the conditions for preservation are not very good, but this, because of the shell matrix, the conditions are amazing in this site. And this is just a preliminary view of the stratigraphy of the site. You can see the different layers from 7,000, around 4,000 years ago. We have a good record of the Middle Holocene there. And there as well, we have evidence of early ceramic production for Amazonian context, 42. I know it's much older here in the Far East, but going back to 4,200 years ago there. But also an interesting pattern of plant cultivation. We have a record of palms, several palms being preserved there. You can see here in the left, these are palm genus, Astucarium, Atalea. But also we find cucurbitaceae, which is squashes, and also Adonacea, which is like tree crops as well. So it's an interesting combination between tree cultivation and short-term tuber cultivation as well. What we also find there is the only evidence that we have so far in the New World of rice domestication. So there's a wild variety of rice that grows in the area there, and we have phytolith data that shows that there was a process of selection towards rice domestication in this area as well. So if you sum up the data that we have so far from southwestern Amazon, we can actually say that this was a center for plant domestication and also plant selection. But what's interesting, I'm just going to read what's written in yellow here. We have a combination of short cycle domesticates with long cycle non-domesticates, such as trees. And I call this agroforestry. It's a combination. If you think about like some form of Neolithic package, we don't have a complete transformation there. Lots of important plants, such as Brazil nuts, which were cultivated there, were never domesticated. And that's the same case with palms as well. And we know today, thanks to genetic data and ethnobotanic data, there's like around 140 plants under different kinds of cultivation, native plants in the Amazon today. And what's interesting is that 70% of these are trees or wood perennials. And I'm talking about the Amazon, but I suspect that the same pattern here could be applied to other tropical places of the world today. Claude Lévi-Strauss, back in 1948, he already noticed that at the opening statement of an important article he's written about plant cultivation in tropical South America. He said that it's very hard to distinguish between wild and cultivated plants in South America. And he says as well that there are many intermediate stages between preservation of plants in their wild state and their true cultivation. I think we should replace intermediate as a concept. I don't think these people are going from one stage to the other. They're just growing plants. I don't have the time to talk about that here, but I think some of these plants are megafaunal fruits, and the extinct megafauna also have an important role in selecting for those cultivars. Anyway, what's interesting is that this data, the archaeological data, it's also backed up by botanical data as well. This is a paper published in 2013. It's a summing up of the distinct tree inventories across the Amazon basin. Every color that you see here, every dot that you see here represents one tree inventory. And the people who wrote this article, they wanted to know, ask some very simple questions, but with difficult answers. And these questions were, how many trees are there in the Amazon? How many tree species are there in the Amazon? And there's a very interesting result that comes in the bottom of those lines. So they found out that there were, unfortunately, because deforestation is growing very fast in the Amazon today, but 390 billion trees across the Amazon, and around 16,000 tree species, not plant species, but only tree species. Well, the most interesting result that they have is that out of those like very high number of tree species, only 227 species, or around 1.5%, represent almost half of the tree species across the Amazon. And they call those species hyperdominant. So they're like lots of variety, many different species, but a very small number of species correspond to almost half of the trees that we find in the Amazon. And if you look at the roster of this, I'm not going to show the 227 species here, but if you look at the 10 most important hyperdominants, you're going to see many palm trees. Many of them are still very important, cultivated by indigenous people, by peasants in the Amazon, but also found in the archaeological records. So what I'm trying to say here is that the botanical and ecological layouts that we see in the Amazon today probably results from indigenous activity in the long term. So what we see today, the configuration of the forest, results from human intervention. One of those species is the rubber tree, one of the 227 species. And the rubber tree has been very important for South America. There was a major economic boom in the late 19th century, early 20th century, regarding the tapping of rubber tapping in the whole Amazon. One important area for rubber tapping was also southwestern Amazon, the Upper Madeira Basin. There were conflicts between Brazil and Bolivia and Peru because of the amount of rubber that could be tapped in this area. There was a problem, however, about bringing this rubber down from the Upper Madeira. The same rapids that I showed before, we have like a stretch of 350 kilometers of rapids that really made it very hard navigation in this area for the rubber to be brought down towards the Atlantic Ocean. So because of that, probably everybody heard of Fitzcarraldo here, like seeing the film by Werner Herzog. Fitzcarraldo was one of the adventurers who were living and hanging out in this area around that time. People were desperately trying to find other ways to bring the rubber from the Upper Madeira towards the main Amazon, away from the Madeira River, away from the rapids. And one of those paths, some people trying to find those paths, was through the Purus River, which is the next tributary to the west. One fellow, Coronel Labre, was one of those adventurers who were trying to find a way to bring the rubber not down the Madeira River. And what did he do? He wrote, that's actually published in English as well. He did an expedition. He funded himself an expedition, and he walked for 20 days. That was a much longer trip. I'm just like talking about the core of the trip here. But with 35 people, he walked for 20 days along 200 kilometers in the hinterlands. 3 minutes. Wow. All right. Okay. And what he found out is that this whole area, it's in Portuguese here, was lined with pets. So he wasn't walking through a pristine forest. He wasn't walking through a pristine forest. He was walking through an area which was, covered by forest, but lined up with pets along the way. It was a network of roads under the forest. Today, part of his trip was in the area covered in green here. That's Bolivia. The forest is still standing there, but at the north, in the Brazilian side, there's a lot of deforestation happening. And because of deforestation, everything that you see there, the dotted lines on the top of those maps, correspond to this kind of sites that have been found in the later years. These are geometric structures. People call them geoglyphs. They date back to around 2,500 years BP, and they go all the way to the present. We've been working some of them. You can see like that's a mounded site with more recent date around the Central Plaza. You can see there's a major linear road coming from it. We suspect that these roads, this is part of the excavation here, the stratigraphic profile of the mounds that we've been excavating. You can see the occupation strata in dark as well. Some of the radiocarbon dates, this is like from the late pre-colonial period. And what's interesting about this, the archaeobotanical record from this site, we see the same pattern as well that we see on the earlier mid-Holocene site. The combination of short-term crops, such as maize, we added together with tree crop cultivation as well. So the same agroforestry pattern that we see starting in the middle Holocene goes all the way to the time just before the arrival of the Europeans. And that's like, we've been like doing drone mapping, and we find like a whole network of roads connecting the sites in this area. You can see on the right there, these are the sites with the roads leaving from them. Also, and I'm getting towards the end of my talk, what we see, I don't have the time to discuss this in detail, but we've been trying to do offsite surveys, excavations in these areas. And what's interesting, basically, that we see a pattern. If we do the excavation outside of the sites, we're getting phyllolate and charcoal data, and we see an interesting pattern, which is a conversion of bamboo forest into palm forest at the time of the occupation of those sites. So when we think about occupying forests, we think about replacing forests by open grasslands, for instance. But what these people are doing there, these indigenous people, they're replacing one kind of forest by another kind of forest. And again, increasing the growth of bamboo, of palm forest there. Again, all those forests today, everything that you see in red now, there in this map are deforestation. I mean, these ecosystems are really threatened. They're not only natural heritage, they're also cultural heritage because they result from human management. And because of the political situation in Brazil now, these landscapes are really being threatened. And to conclude, what can we say then? We have, and again, that's the one before the last. Yeah. I mean, we have evidence of early human occupation there, like going back to 9,000 years ago. We have evidence of early domestication, but I don't think we have agriculture there, not in the classic way. I mean, there's something else going on. I have to come with another name, and also no states. I mean, we also see different temporalities mixed in landscapes which are being raised today, as I mentioned before. And I mean, what we see, if you look at the language data that I mentioned, like we have biological hyperdiversity, but also cultural hyperdiversity represented on the language diversity in the area. Non-domesticates are as important as domesticates in this area. And can we call them incipient farmers after all these years? I think no. I mean, we should remove the word incipient. And one lesson that we have to learn by looking at this kind of evidence is to know how to manage abundance. That's my last slide here. In the Amazon, but elsewhere in the world, notions of development are embedded in concept of progress, of linear time, and of accumulation. Such notions became naturalized, and worse, they inform public policies today throughout the tropics, not only in the Amazon, but in the developing world as well. But by looking at the deep past, I think archaeology can be a powerful tool to falsify these ideas and to show their political content. Thank you very much.